So we can start adding components to our circuit schematic, but obviously we need to know which components to add. So in this project we're going to be building the gamepad for the K64F. So this is going to plug on top of the K64F that contain an LCD, various buttons and joysticks, as you can see in this picture here. These 4 buttons here, 2 kind of shoulder buttons, joystick, start and back button. Got 6 LEDs on the front to display information to the user, as well as 6 current limiting resistors, on-off power switch, connections for a 9-volt battery, piezo for generating audio, and a potentiometer just for changing whatever volume or speed or something. So you can see these are the that's roughly what that is what the PCB looks like. And in the lab notes you can find the bill of materials. So the bill of materials tells us what components and the quantity of components are in the PCB. So we need to start adding these to our schematic. So I'll go to Eagle. So you can see on Eagle here this cross. This is like the origin of the that's the origin of the schematic. You can use this to zoom. Use these tools to zoom in and out. So the first thing that I'm going to do is add a frame. So it just makes it look nice when you print your schematic. So inside this gamepad library you'll find this A4 landscape frame. So I'm just going to drop that on the origin. It's a bit annoying when you drop something, you can see I've still got another one to drop ready, but in this case we don't want to drop a second one, so I'll press escape. That takes you back to here, cancel, and then I'll zoom back out. So now we've got our frame, so we can start putting the components in here. But this won't be big enough to contain everything, so we can create a different sheet. So on this drop down menu here, I'm going to create a second sheet. And again I'm going to add in a frame on this one. Put it there again, escape, double click on escape. So now we've got our 2 sheets. So 1 and 2, each with a nice frame on it. So you can, in this box here, you can use a text tool to put, you want to put your name in or something. So for this one, select the 94th layer. So you can see the text tool there is green because it's on nets, but the text we tend to put in this symbols layer. So I've selected 94. And then also in the library you can find the logo. There's a small and large logo. So you might want to drop that into your schematic as well. So you can just put information in here just to make it, give the user information once they print it out. So in this first sheet I'm going to add in the K64F. So you can find this. So this is a shield for the K64F. So you can see the components have got 2 parts. So this is it. So the K64F shield is the device itself, and then it's split into the schematic part. So the symbol what appears on the schematic, and then this board part as well. So this is a footprint. So this corresponds to actual physical dimensions. It tells us where the actual pins are on the device. So I'll drop that in. You can see this is quite large, so we're not going to fit a lot more into this display. Into this sheet, sorry. Then we'll also put our LCD in this as well. So again, we can see the circuit schematic symbol for that, and then the actual physical layout for this. So I'll drop this in sheet 1, then we'll go to sheet 2, and we'll start adding the different things in. So I can see from here we put the shield in. We need to add the joystick in. So I'll just drop that in. We've got 4 large buttons. So you see, in this there's the component called button, but there's different types of buttons. So you see we've got large, small, and side buttons. So we'll get the large one. So we'll put the 4 in. 1, 2, 3, 4. So that's 4 large buttons. And we need 2 small buttons. So go and select the button part, but this time select small. So we need 2 of those. And then 2 right angle buttons. So these are the side ones. So these are mounted to the side. We'll put these on the shoulder of the gamepad. So that's 8 buttons in total. I've got 6 LEDs and 6 resistors. So we're going to be using surface mount components here. So this 1206 refers to the size of the component. So it's 12mm long by 6mm wide. So find LED. So this is a surface mount package, the 1206 package. So I'll stick those 6 in. And we need a resistor for each of those to limit the current. So you can see, well, if you right click, you can see it can rotate. So I'll just put a resistor. No, I'm trying to match them up as well, because that you can see they get numbered. So LED 1, 2, 3, 4, 5, 6. So I've put it so R1, R2, R3, R4, R6 is underneath. And we've got the piezo and potentiometer, so I'll add those parts in. So here I'm just scrolling on the mouse wheel so I can zoom in and out. So add the potentiometer, and the piezo. Now we did the slide switch. This is a power switch I use to turn it on and off, sorry. And we've also got the clip as well, because it's going to be powered by a 9V battery. So this is the part to connect a 9V battery. So I've added all those into in sheet 2. We've got all the components, in sheet 1 we've got the Nokia display and the shield for the K64F. So I'm just going to save it now, just while we've added those in. So now we can start giving names to these different components. So I'll go back to the next sheet. So the buttons, so the top 4 are the big buttons. So we don't want to call the buttons B1, B2, B3 and B4. We'll call them A, B, X and Y, like you find on an Xbox controller. So this tool on the side here, this is a name tool, so I can select the name tool and click on the button. So that'll be button A, this one B, X, Y. So the next 2 buttons, these are the smaller buttons, so we'll use them for the back and the start button. So I'll call that back, start. And then for these last 2, the shoulder buttons, I'll call them L and R for left and right. So we've got our components in the schematic. We've named the ones that we need to. Now we need to add some power supply connections as well. So in that library you'll find, so we've got 3V3, so 3.3 volts. So that's for the microcontroller. So I'll just drop that in into the schematic. Got 9 volts as well, so this is going to be our battery voltage. And I'll just drop in a ground as well, so the ground supply symbol. So I tend to just put these in the schematic, and then you can use a copy tool. So this symbol here, and later we can just click on the ground and copy it. So to start, we can now start doing connections. So all these buttons here, they're going to have to connect to 3.3. Well, one side will connect to 3.3 volts, the other side will connect to the pin. So I'll just shift the 3V3 symbol. So this is using the move tool here. I'll move it over here. So I can start connecting. I'll connect up the left side of the buttons to 3V3. So on the microcontroller, we'll turn pull down resistors on, so when we press the button it'll connect to this 3.3 rail, so we'll read 1 when we press the button. So we draw the connections using this draw tool. We need to make sure the nets layer is selected. So I'll just draw for you. So you can see it's very easy. Just double click just to finish the line. And I'm just all the buttons are gonna connect to 3.3 volts. I'll just connect all those up. Now, even though it's towards it's obvious these are connected, Eagle will warn you later, so you need to put a junction in, so on a net junction. So each of these wires is called a net. You can put a junction up just to kind of force the nets to be connected. So they're all connected now. And the other side we're going to connect to the microcontroller pins. So the pin out for the PCB is here. So this, I designed this, looking at the Mbed API. So what buttons need to be on interrupting pins, and then getting some pin numbers from the Mbed pinout. So A is going to be connected to PTB9. So we can, rather than drawing lines from here to the microcontroller on this sheet, we can actually name the nets. And if you give two nets the same name, it kind of electrically connects them even if they're not physically connected. So I'm just going to draw on each one of these a small length of net. And then using this label tool here, so label, I prefer this style. So this is select a label tool, and here you can configure things. I prefer this style. So I'm just going to click on those now, so that'll label these nets. So we can see by default the nets are called $N$1 for the first one. You do $N$2, 3, 4, and so on. So I'm just going to rename these nets. So using the name tool we used before, I'll click on here. I'm just going to call this net A, B, X, Y, back. And according to this pinout, so A is going to be on PTB9. So I'll switch to this one, find PTB9. Where is PTB9? There it is. So I'll do the same process here. So on PTB9 I'll draw a small length of net, label it, then name this A, so just to double check. Yeah, so A is PTB9. Use the name tool. I'll call that A. So it can't now connect $N$1 and A, so yes. And they're now connected, even though they're on different sheets. They're still connected. So you can just do the same thing for the buttons. So we'll do the LEDs using a similar process. So these are going to be active low, like the onboard K64 LEDs are. So the anode of the LED will be connected to 3.3 volts, and then we'll go to the current limiting resistor, and then this side will connect to the pin. So we make the LED come on by making the pin low. So I'll just get the 3.3 volt symbol before. I'll just copy that. I'll put that here. I can just start drawing these lines in. Okay, that's all the anodes to 3.3. Not forgetting the junctions. I might wire up these gaps. And then just do the same thing again, so I'll just put a short length on there, add a label on. So I'm going to right click to rotate, and I'll give this a name, LED1. So then we can check our pinout, so LED1, so that's PTA1. So LED1 connects to PTA1. So that's a PWM pin, so that's going to be marked up as a PWM. So PTA1 is here. So put another length there. Add a label. Give it a name, LED1. So this will ask us whether they want to connect. Yes. And you can just repeat the same principle for the rest of the LEDs. We'll do the battery connection now. So I'll just I'll move the battery, and I'll use one of these grounds. So we need to connect the ground of the battery to the ground symbol, and then with this switch, so this is the on and off switch, put it here. And I get the 9-volt supply symbol, move that over here. So I just need to connect this to one of them. That means when the switch is in this position, the battery is not connected. Then we slide the switch to here, and this will connect, the battery to this 9-volt symbol. So I will just connect those like that. So we just got those two terminals connected. So when the switch is in that position, we're not going to be connected to anything. And I close the switch to make the connection to plus 9 volts. So I'll just copy that symbol, the 9 volts. I'm going to put that. It looks like you can't copy between sheets, so I need to add one to this sheet. So add the 9 volts. So that needs to go into the V in. And I'm going to connect up that bin. And I'll do the grounds here while as I get all the powers done while we're here. So add in the ground. I'll just connect. How's that this? Let's put a net there just to force it to be connected. There's another ground symbol over here. So copy this ground. So you can if you overlap the pins like that and then move it just to check that it's connected, it saves drawing the line. So there's one more as well here. So we've got our power connections done. So the K64F has got this onboard 3V3 or 3.3 volt regulator. So we'll put our 9 volts into V in. This onboard regulator will turn it to 3.3 volts. So we'll add that supply in. So put this here. And put a junction in. So we're putting 9 volts into the V in pin. The K64F will regulate that down to 3.3 volts. That's connected to this symbol in Eagle, so it means all of those symbols, so these 3.3 volts are going to come from the K64F 3.3 volt pin. So the joystick, we now set up the joystick. So we're going to need the 3.3 volts for that. So I'll just copy this symbol. So I'll just copy these. So that's the horizontal pot, vertical pot. Again, add a junction in there just to stop it moaning. And the ground symbol, move this. I'll just put this down here. So the vertical, so the up-down one is connected to P2B10. So the same idea now, just add a bit of a netting, add a label, rotate it, and I'll call that vert. And then do the same for the horizontal. So you need to go to the my control and add that on. So the vertical was P2B10. So that's one of these analog pins down here. P2B10, there we go. I'll just give that. Let's double check. PTB10. This is a vertical one. So you can just do the same for the horizontal and the button. The display. So we could put the power on the display as well, so I'll just copy the grain symbol from here. Let's connect that to the copy the 3v3. Put that in. So we wide up the Nokia display, and we can obviously do the same depending on these pins for the LCD. I can just connect up here. The piezo, actually we need a grain connection for the piezo, so I'll do that. So that side of the piezo connects to grain, and then positive will go to the pin. So in this pin out, the piezo goes to PTC10, so you can connect that up as you've done before. And then finally we've just got the potentiometer. So again, the potentiometer, we need to connect one side of it to ground, and the other side to 3v3. And we can just do the same again, so add a net here, give it a label, and connect it to PTB2. So by using these labels, it's much easier, rather than having to draw loads of wires going everywhere, it's much easier. Makes your schematic much neater. So you should be able to fill in the rest of those tracks now to get your completed schematic.